We were talking about the Bohr model, and we said that it was great as far as it went. It worked for the hydrogen atom. Unfortunately, it didn't work for any of the other atoms. And so early in the 20th century, so that's back in the early 1900s, which now is like 100 years ago, the quantum mechanical model was developed, and that replaced the Bohr model. This was revolutionary because instead of depicting electrons as being particles that are flying through space, it said that they actually act as particles and as waves. And so it was just a completely different way of thinking about the structure of the atom. So in the Bohr model, we had orbits, which are nice and easy to understand because we can visualize them being like the solar system. In the quantum mechanical model, we have something called an orbital. So the words are very similar, and yet they're extremely different from each other. So an orbit is a path, a circular path that an electron is traveling in. We get that. An orbital is very, very different. It's actually a probability map. It's a region of probability where we say, well, the electron is probably in this region, but we can't say for sure. So it's a probability map of where the electron is likely to be found. So we have to think about this a little bit. So we're going to compare baseballs with electrons. Baseballs act as particles. They act as objects. And if you have a pitcher pitching a baseball over home plate, it's predictable where that baseball is going to be. And if the pitcher pitches it in exactly the same way, the ball will go in exactly the same place. The catcher can put his mitt up and catch it every time. You can even, take photographs and fast speed film of it, and you can calculate its trajectory and do all kinds of cool stuff like that. The electron, now obviously they're too small to throw, but if you could throw an electron, even if you threw it in exactly the same way every single time, it would go somewhere different every time. And this is not relative to anything that we have experience with, because it just doesn't happen that way. If you throw an object in the same way, it goes in the same direction every time. Electrons don't do that. And so this is just really kind of a freaky thing. Why is that? Well, electrons and photons, which are particles of light, have what we call wave-particle duality. They act as waves in some ways, and they act as particles in other ways. And so if we're trying to describe the behavior of a pitched electron, we can't say, oh, it's going to follow this trajectory, and if we throw it the same way, it's going to do the same thing. All we can do is pitch the electron and then observe where it goes. And so what they've done here is, we're pretending to pitch electrons at this batter. Maybe one of you knows who that is. And each of these white dots represents where an electron went. And so if we pitched electrons at the catcher, most of the time they would go in the center, but sometimes they would not be in the center. But if we made a measurement of where they went every time, we could develop a probability map and say, okay, well, inside this circle, the electrons were 20% of the time. And in this larger circle, the electron went 40% of the time. Inside this larger circle, 70% of the time, the electron will go into that region. But you pitch an electron at the catcher, it could go in the opposite direction. It could go off to the left. It could be up here and hit him in the helmet. 30% of the time, it doesn't even go within that circle. So we can't predict exactly where it's going to go, but we can observe and say, well, 70% of the time it's going to land within this region. And that's what orbitals do, is they say, well, a certain percentage of the time this is where the electrons are. So an orbit is a circular path that shows the electron's motion. It's very predictable. An orbital is a probability map. And it's really important to understand the difference between them. It's the relative likelihood of an electron being found at various locations. It's completely unpredictable. Electrons are completely unpredictable. Well, we'll do that when we get to the other picture.